This is Riley's Maths videos. This is the third in our sets videos. We're looking at Venn diagrams today, and what we're going to look at is what is a Venn diagram, what are the different shapes of Venn diagrams we might have, and about these two ideas of intersection and union, and finally how to draw a Venn diagram. So let's just talk briefly about what a Venn diagram is. So far we've been looking at sets. For example, we might have set X, which is the numbers from 1 to 5. A very straightforward set. Okay, that's the set X. If we wanted to draw a diagram to represent set X, which has 5 elements, 1, 2, 3, 4, and 5, we would draw what they call a closed curve, but it's basically just a circle. We'd call it X, and we put our numbers from that set into our circle. That is called a Venn diagram. Now that's a very basic Venn diagram, but it's still a Venn diagram. It's a picture that represents the set X. Now, some Venn diagrams will take on different shapes to others. So for instance, say I had this set X, but say I had a set Y, which was 1, 2, 3. Then I might draw that like this. I might put set Y like this, 1, 2, 3, and I might put set X outside of set Y, and it would have 4 and 5, because inside set Y there's elements 1, 2, 3. Inside the circle set X there's elements 4, 5, 1, 2, and 3. Even though these elements are in set Y, they're also in set X. So 1, 2, 3, 4, 5, they're all inside the X circle. That's a very unusual case, but we do come across it. And what I hope you've spotted is it means that Y is a subset of X. In other words, everything in Y is in set X. And how we write that is Y with this kind of flattened C, X. Okay. Remember quickly as well that we have other notation that we've looked at. So we've seen, for instance, I could say here that 1 is an element of X. That means 1 is in set X. I could write down that 3 is an element of Y because 3 is in set Y. I could write down that 4 is not an element of set Y because 4 is not in set Y. It's not inside the circle Y, and it's not in the set Y. Okay, let's keep going with X here, being 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And let's take a set Z, and let's say that in set Z is 2, 4, 6, 8. Now, if I was to draw a Venn diagram for this, I couldn't just do set X and put set Z in it, because Z is not a subset of X, is it? Z is not a subset of X. So not everything in Z is in X. So I have to have a different way of drawing a Venn diagram, and you'll have seen that at the top of the page when I drew my Venn diagram like this. So this would be set X, and this would be set Z. Now, I was going to draw it separately, but actually, let's look at it and see. I'm going to draw it overlapping, and you'll see why now. Make that into a big Z. Okay. Anything that's in set X, like we saw up here, has to go in the circle that's labeled X. So 1, 2, 3, 4, and 5 have to go into this circle. So let's put them in. 1, 2, 3, 4, and 5. Anything in set Z has to go in circle Z. So let's put them in. 2, 4, 6, 8. But hopefully you've spotted, oh, that's a problem, because look, in this one Venn diagram, I have a 4 over here and I have a 4 over here. So which set is it in? Is it in set X or is it in set Z? It's in both sets, isn't it? So we have to have a way of showing when there's numbers that are in both sets we're drawing. So let's scribble that out and let's draw another one. Here's X, here's Z. And if you were shouting at the screen, well done. Hopefully you're saying, but what about the middle space? Because that middle space is not only in set X, it's also in set Z. This space in the middle is in this circle X, but it's also in this circle Z. So what I'm going to do is I'm going to put the ones in the middle that I just picked out as being in both sets. So what's in both sets? 2 and 4 are in set X and in set Z. So they go in the middle. What else goes in set X then is everything else from set X. So 1, 3, and 5. So in set X now I have 1, 2, 3, 4, 5, and in set Z I have 2, 4, 6, and 8. Okay, now we have some special terms and special symbols we use. And what we have is this symbol, which is like an upside down, well, it's like an N, but without a little tag on it, and that means intersection. And if you think about two roads intersecting, there's a road, and there's another road coming the other way. In America, they call this the intersection. The intersection is the overlap of the two circles. Okay, it's the bit that contains elements that are in both sets. So this area here, 2, 4, is in the intersection. Okay, so the intersection is the bit where they overlap. And then we have the union, which is like a U but without the tag, union, and that is all the circles, or both the circles, sometimes we have 3 circles though, all the circles, all the elements joined together. So in union, it would be 1, 3, 5, 2, 4, 6, 8. That would be the set. That's the union of X and Z. How do we write that? We write that X intersection Z equals, and we draw curly brackets because it's a set in itself, X intersection Z equals 2, 4, and X union Z equals 1, 3, 5, 2, 4, 6, 8, everything in the 2 sets. Okay, hopefully that's enough for you. I'm going to do another quick video with some more examples if you need to look at video 4.